Hello, ladies and gentlemen. How are you doing wherever you are? I do hope you're doing fine. I'm also doing okay here. Welcome again to this channel. We are interested in architecture, engineering, and construction, and that is what we teach here. Today, I want to speak about how to decide the orientation of columns in a building. I mean, if you're a designer, you have received a plan from an architect. You have to decide the orientation of your building. I mean, the orientation of your columns. Because the way you're going to orient your columns is very important. In terms of resisting lateral loads and also some other variables. So that is what I want to take some few minutes here that we tackle together. So that it won't intimidate you again. So, well, the first thing is that the moment you get a drawing, you first have to, you have to decide the sizes of your members. From preliminary designs, then you have to know how to orient, these members. Today I'm not going to speak about how to size these members. Maybe we'll do another video to take care of that. But today I want to speak about how we really orient these columns, because sometimes people do make a mistake in that. Well, so if you want to listen to that, you'll never be intimidated again. Just keep it here. I'm going to do that in the shortest minutes possible. Well, so as usual, let us take a sketch to help with our understanding. Well, so suppose you have, let's say we have a plan, just a simple plan like this one here, and you want to orient your what I mean by orienting is this: you want to which direction do you want to place your columns in. So assume what I mean is this: if you have a column, let's say a 600 by 300 column. It is not a square column. If it is a square column, you can just orient it anyhow, right? But what if it is a rectangular column? Want to make the best use of this section possible. So if it is a 600 by 300 column, in what direction will you place that column? Will you place it with the longer side parallel to this direction, like this one here, or will you place it with the longer direction parallel to this other direction, like this? That is the big question today, which we want to answer. So if you really want to know the answer for this, just keep it here. Well, so the idea is that this building has to resist lateral loads. It has to resist earthquake loads, it has to resist wind loads, and all those. So what happens if a wind load acts on this building? Let's say a wind load acts in this building from this direction, right? How will this building behave? Well, this is how the building will behave. We'll have let's say we have, so if the wind load is acting in this direction, then we'll have this building something like this. This is the longer dimension of the building, this is the length, this one here, this is the longer dimension. If you look at this building from here, this direction of the wind load, then this is the longer dimension, right? Because this one is the shorter dimension where wind is acting from. Well, so that means if wind is acting from this direction, this building will behave like a cantilever. How do cantilever behave? Suppose we assume that it is fixed at the bottom here, then this building will tend to bend. I can use a different color for that. This building will tend to bend in this manner, to resist that wind load. This building will bend in this manner. Well, suppose we also apply some wind load. There is also some wind load in this direction. What will we see? This is how the building will behave. So we are applying the wind from this side. That means only this dimension, the smaller dimension, is the one which will be resisting that wind load. So here we have this one to be the width. This one is the width. This one is now not the length. This is the width of the building. This one here, smaller dimension. So again, if we apply wind in this direction, then how will this building behave? Of course it will bend in this direction, right? So assuming that it is a cantilever, it is fixed at this point, right? It is fixed at this point. So which one is critical? Is it critical this building bending in this direction, or is it critical this building bending in this direction? Of course, we've assumed that this is a cantilever. So this is a cantilever beam with a very big depth, and this one is a cantilever beam with a very small depth. Which one will be affected? Which one will be more severe? Of course, the one with the smaller depth will be the most severe one, right? Because we are applying the same moment and the depth is small. That means this beam will bend so greatly, and here we are applying the same moment and the depth is so big, the depth of the beam is so big. That means it has a good resistance. That means the bending is not severe in this direction. That means what I mean, that if wind load is coming in this direction, then it is not severe to this building as compared to when it is coming from this direction. Why? Because from this direction it is only resisted by this width, and the width is smaller, so it is like a shallow beam, so it is only resisted by this width here, but if it is acting from this direction, then it is resisted by this length here, which is acting as a deep beam, so which one is worse? Of course, we've agreed that this one here is the worst one, right? Yeah, because it is bending the beam in the shorter width, so what happens is that for these columns to have good resistance, these columns, we must orient them in this direction, you see, we must orient them in this direction so that the longer dimension of the column is parallel, to the direction of this moment, so that this column will bend in this direction, and the longer dimension of the column will be taking care of that bending, The same thing with these ones. We've talked about the building. Let us now talk about the columns. So if this is a column and this is the smaller dimension, if the smaller dimension is the one bending, then this one is more severe. But if the longer dimension is the one resisting the bending, then this one is less severe, right? So we have to put our columns in such a way that the longer dimensions are the ones resisting the wind loads, the moments due to the winds or the lateral loads, But of course there are quite a number of variables which comes to play. So as an engineer, you have to check all your variables and to ensure that you make the best decision ever. So what I'm saying is that if the wind is blowing from this direction, then you need to orient your columns in such a way that the side which will be involved in bending is the longer side. In short, it will be bending about the major axis, right? If you make your column to bend about the minor axis, like example is this one here, if it is bending about this minor axis, then it won't resist a lot of moments, But if it is bending about the major axis, then it is acting like a deep beam. That means it has greater resistance to moments. I think up to that point it will never intimidate you again how to orient your columns, It's as simple as that. So that is it. Very simple concept. If you want to orient your columns, check which direction is severe with your wind loads. Then you make sure that you make your columns to carry that load by bending about the major axis. That is it, ladies and gentlemen. I don't think I have more. I just wanted to speak about the concept, the background, how you decide to orient your columns. That is it for now. Thank you so much for watching. If you have any issues, kindly put them in the comment section, and if you really find this video helpful, don't forget to subscribe, and don't forget to share it with your friends. Don't forget to give me thumbs up, so that next time I produce the same, so that we continue with the process of sharing knowledge. That is it. Wherever you are, I wish you a good time. I wish you a good evening. I wish you a good morning. I wish you a good afternoon, wherever you are from the world. I'm in Kenya, and right now it is 9:30 p.m. That means people are about to sleep. Some are already sleeping, so wherever you are, have some nice time. We shall connect again in this channel next time. Otherwise, thank you for being with me up to the end. I do appreciate. Bye.